Hello everyone. Today our topic is carpooling or sharing system. So me and my teammates were going to take this topic. So this is the outlines are there. First we are covering the introduction part, then the related work about that, then the gaps and problem statement, then the objectives, and then the existing model, what the existing model is there, then proposed model, that what the gonna propose there, and then the conclusion and the references. So basically the introduction. So carpooling is the practice of two or more individuals sharing a single vehicle for commuting or traveling to a common destinations, thereby reducing the number of vehicles on the road. Historical origins, we can say carpooling gained prominence during the World War II. Earlier ride-sharing initiatives date back in the 1920s. Impact is like carpooling reduced traffic congestion and all the things. So, like, what is the importance of our application? So, basic issue is like centralized carpool services, control user data. Like, if you ever heard about the Uber and Ola, they use the control users data. They have the overall overall control of the user data. Objective: create a blockchain based system for securing and direct driver to rider connection. The advantages we can say is enhanced privacy, reliability, and security. Impact should be disrupt traditional carpooling models, ensuring data protection. Efficiency, streamline carpooling.
Okay, so quickly we'll just go through the research papers that we went through. So one of them is here. This is basically it was a paper that analyzed how to design a secure decentralized car sharing system using blockchain. So of course the adopted methodology we can see was just a decentralized model based on blockchain, and the features of course are once again is data integrity, authentication, and decentralization. And certain challenges, as we have already explained before, is was scalability, user adoption, and cost efficiency. Moving on to the next one, the second paper was a similar one, but it was based on trying to utilize Ethereum's smart contracts and Solidity programming language also. So it was trying to use two different token types, ERC721 and ERC20, as you can see it's mentioned here. And it was with the help of the integration of IPFS, which is basically the interplanetary file system, to reduce the cost of Ethereum transactions. And of course, the challenges, as mentioned here, are security and stability and integration. I mean, maintaining all this in a good environment was a major challenge. The next paper was relating to an efficient secular ad hoc vehicular networking architecture based on blockchain, of course. So, as in short, IOV. So the features were evident that once again the security enhancement and information sharing. How the uh, necessary and the significant information was just being shared among the important stakeholders. Like the drivers, auto manufacturers, insurance companies, and service providers. For further processing and various other applications. Certain challenges immediately that we discovered were privacy and security, and of course resource allocation. How to efficiently manage and allocate network resources among all the parties involved. And here's a summary of the last three papers I just spoke about quickly, just to recollect. It was the scalability challenges, how do we scale it in a large scale, vertically and horizontally, of course, user adoption and trust issues, privacy preservation, regulatory compliance. Pretty much, most of it is self-explanatory. Uh, but another exciting or interesting one was the real world testing. How do we implement this in the real world and get it up running as a price, you know and data integration and security vulnerabilities. So this was all about the research papers we went through.
So here our problem statement is developing a blockchain powered solution for secure and efficient global peer-to-peer carpooling networks. So our objectives is data privacy enhancing, facilitate the user authentication, improve payment efficiency, foster trust among users, enable global accessibility, enhance user control, reduce administrative overheads, streamline dispute resolutions, ensure data integrity, enable cross-border compatibility. So this is our existing methodologies, like what the Ola and Uber, all these kind of persons are using. So what they are using is like they're using the data of the driver and the data of the customer. So they are having that data. So that is not safe, that is not private, we are saying. So what we are creating is that we are creating a secure network through the help of the blockchain.
In our proposed methodology, we are using the blockchain network. We plan to store all the required data such as car request, retrieve balance and other such functionalities within a smart contract, which whenever required will be updated into the blockchain. The customer and the owner will be able to access the smart network through our software and will be able to do all the required transactions. All the data will be encrypted and stored over the blockchain, so all the data is also secure.
So now I will be explaining technology to be used in the carpooling system. The latest technology that will be used for this studies are the blockchain technology, in which secure transparency and keeping of the records or the transaction which has been happened is done by the blockchain technology. Identity verification uh, using biometrics, decentralized uh, identity system, like by specifically dividing the identification, which you can say is either a little bit uh, scary or not, like the person who is taking more time for biometric verification is sorted in decentralized identity system. Tokenization. Tokenization, we will be using giving records and payment tokens. Like once the payment is done, we will be showing a pop-up in which the payment transaction ID and a few rewards in the form of like an example, Ola coins, which will be only used inside the app. They can't be transferred as a cash outside. Now, payment integration, secure gateway and cryptocurrency. So payment integration is like cryptocurrency is necessary because payment should be secured, like by using your private key you can do your payment using, like we can say, an OTP is a private key. So now moving on to requirements. So on now requirements, like the requirements will be hardware requirements, in which server infrastructure like as web servers and blockchain nodes will be used. In database servers, database management storage, and the data will be stored in offline as well as in online in the cloud form manner. Now for storage, data storage and scalability, GPS and geolocation devices like location tracking, geospatial data, like location tracking is both useful for the driver as well as for the customer. Like transparency will be maintained. And one more thing, behind for location, the company which is holding this system will be also keeping track of the driver which is necessary. Now for software requirements, blockchain platform. So blockchain platform, they will be giving providing distributed ledger, cryptocurrency as I explained before for secure payment transaction, consensus mechanism which is used in all the blockchain systems or any applications, and especially used in our carpooling system, smart contracts, self-executing contracts, code-based agreements, automations. Like self-executing contracts in the sense, like a specific module will be provided for each of the system, and which will be executed separately on basis of like one part of the system won't affect the other. The same explanation is for the automation. Now, like a requirement, one more requirement is Oracle, real world data, data feeds, external data integration. If necessary, external data integration will be used uh, using the Oracle system.
Now coming to the national status, in India, car sharing primarily operates through platforms like Ola. Ola offers various transportation options. Now coming to technical infrastructure of Ola, the first point we're going to discuss is database management. Ola employs PostgreSQL SQL and MySQL for transactional data and user profiles. They also use NoSQL databases like MongoDB for large-scale database. The second point under technical infrastructure is real-time matching engine. Ola's real-time matching engine utilizes Apache Kafka for data streaming and Apache Spark for data processing, enabling it to have dynamic route matching. The next point is geospatial technology. Ola relies on geospatial databases and tools like PostGIS for efficient location data management. The next point, payment gateway integration. Ola integrates payment gateways like Razorpay and PayU for seamless financial transactions. The next point under technical infrastructure is machine learning and data analytics. Ola uses machine learning to optimize matches, predict demands, and adjust pricing, employing data analytics tools like Apache Hadoop and Apache Flink. The next is user authentication and verification. Ola ensures secure user identity management with robust authentication systems like OAuth and OpenID Connect. Now coming to the international status of carpooling. Car sharing operates internationally with platforms like Uber. The technical infrastructure of Uber. The first point is database management. Uber manages its data using a combination of relational databases such as MySQL and PostgreSQL for transactional data, and NoSQL databases like Cassandra and DynamoDB for scalability. The next point is real-time matching engine. Uber's real-time matching engine relies on technology like Apache Kafka for data streaming and Apache Flink for data processing, enabling to have a dynamic ride matching. Now coming to geospatial technology, Uber uses tools like H3 and GeoHash for efficient location data management. The next point, payment gateway integration. Uber integrates with multiple payment gateways like Braintree and Adyen to facilitate secure and frictionless financial transactions. The next point, machine learning and data analytics. Uber leverages machine learning features which are supported by platforms like Apache Hadoop and Apache Spark. The last point, user authentication and verification. Uber employs robust user authentication and verification systems, often utilizing OAuth and phone number verification for secure user identity management.
Now we shall discuss the different methodologies that have been used in our software. The owner class was created, which will contain all the required data of the owner. So it will contain attributes such as the contract, balance, car, and pending request, through which he will be able to approve new cars. Different methodologies will also include the methods that were there in the class. So we can say add car, deploy, which will allow us to deploy blockchain, withdraw earnings through which he can get back all the earnings, and several other functionalities. Similarly, we also have the customer class, which will also contain the attributes and methods specific to the customer. Then we have the car class, which has only attributes and no methodologies of its own. Next, the smart contract, which is the main part of our program, which have attributes such as the ID of the contract, client balance, owner balance, and such specifications, which should be stored in the blockchain. It also contains methods, which such as retrieve balance, withdraw earnings, and so on, which will be implemented via the blockchain. And then we have the booking details class, which has its own attributes and methods related to the booking requirements. Then the most important class, the blockchain class, which has helped us implement our own blockchain through which all the transactions are taking place. So we shall discuss this in detail. The attributes related to blockchain class are the unconfirmed transactions and the chain. The unconfirmed transactions basically contains a smart contract which have not yet been added to the blockchain. The chain itself is the blockchain that we are speaking of. Next, the methodologies. Create Genesis block is the first block that will be created. Last block refers to the last block that was updated in the blockchain. Add block will help us add a new block. Proof of work is one of the algorithms that we are using to mine for new blocks. Add new transactions helps us to add new transactions to the smart contract. Get unconfirmed transactions returns the smart contracts that have not yet been added. Is valid proof returns whether the hash block is valid. Check chain validity checks if the blockchain is still untampered and there have been no unregistered changes. Mine helps us to mine for new blocks. Now let us discuss the algorithms that we have used in the software. The proof of work algorithm helps us to validate the existing blocks and check if the new blocks that are being mined are also valid. The mining algorithm in turn helps us find new values for the blockchain that are going to be verified by the proof of work algorithm. Now let us discuss the outcomes of our software. A mini blockchain has been created a smart contract has been established, which helps us facilitate the different transactions that are happening in the blockchain. A car sharing system allows us to do functions such as add cars and retrieve their earnings, or approve cars for rental. Customer class will help customers book cars and for any number of days, and to pay the amounts that they are due. The encrypt and storage will help us encrypt and store data into the blockchain, and the user interactions will be done through the main script, which will help them choose what they want to do in our current software. Now let us discuss how our software actually looks. Initially, we will be thrown a menu through which the customer or the owner can choose their requirement or choices basically. So first we need to add new users into our software. So we use choice 1, that was add new users. So we have here added 2 new owners to our software and 3 new customers to our software. The next option is check balance. Here as an example, we have checked the example of ID user 1 who was an owner and who had a balance of 500. Next, we deploy the blockchain through the owner. So the choice will be number 4. The owner ID was 3, but since 3 was a customer in our input, so the customers cannot add anything into the blockchain. Next, we give owner ID 1 and ask the user to enter how much amount they want to deploy. 1,000, but since 1,000 was greater than their balance, they cannot deploy. Next, we asked our input again. The input was 200, and the 200 Ethereum was successfully deployed into our blockchain. Next, the owners are required to add cars into the blockchain. So as an example, the owner ID 1 has added a car, then owner ID 1 has added another car, and owner ID 2 has added one car with different rates just for our example's sake. The next option was just added so that we can visualize all the data that has been entered by us into the system. The next choice is to rent a new car. So first we give an input 1. 1 was an owner, so he is not allowed to borrow cars. Next we give the input 3. 3 is a customer, so the list of available cars is thrown to the customer. The customer has free choice to choose which car he wishes to borrow. Next, he enters the amount as deposit, which basically indicates how many days he is planning to borrow the car for. Next, the choice is 8, which encrypts all the data that has been stored in the smart contract into the blockchain. No specific output is shown to us, but in the backend, the data has been encrypted. The next option is to withdraw earnings by the owner. As we had seen in the previous slide, the customer had deposited 200 rupees to owner 1. So owner 1 is easily able to withdraw this amount into their account. The next option is for the customer to see how much money they have deposited and left it. For example, customer 4 had not yet done any transaction, so it says no money to withdraw. Whereas customer 3 had deposited 200 Ethereum, and that much was unwithdrawn from their earnings. The next option was to exit. So thank you. Now let us discuss the pseudocode for our software. Right now you can see the code for displaying the menu and seeing and the options that can be chosen. As the choices are made, each choice relates to its own small functions or their small criteria, which checks what has to be done according to the option that has been chosen. These are some more options as we can see. Then the final output shows the final choice was 11, so thank you. And if any invalid input is given, then it will ask to re-input a valid input. Then the if name equal main just checks that the function that is being called currently when we run the program is the main function. If not, then the program is not supposed to run as the wrong class has been called. Now let us discuss few of the results that we have come across after this software was developed. In comparison to other softwares, this is a simple implementation and is only meant for understanding purposes. But in a real world application, more advanced features would be required and actual security measures would be necessary. The enhancements that we can build to this code would benefit uh, with additional features such as more robust consensus mechanism and other better looking user feedbacks. The integration of real blockchain platforms would also help. As this was only a simulation, we have only created a blockchain through our own programming code and are not using an actual blockchain.
Conclusion: Our blockchain-based carpooling system has the potential to revolutionize the way we share rides and manage transportation. It offers improved trust through its transparent and secure technology by reducing costs for participants, enhancing data privacy, and contributes to environmental benefits by decreasing the number of vehicles on the road. By addressing many of the shortcomings of traditional carpooling services, it presents an exciting and forward-thinking solution for more efficient, cost-effective, and environmentally sustainable transportation in future. Here are the references which we have used to make this PPT. Thank you.